Alright, so I've got this coil. It's a Slayer coil that you can buy from Gary Bluer. Um, it's the secondary. It's got to be a 3-inch pipe, and it's probably about a foot long, a little over a foot long. I've got the top of the probe at the top of the coil and the bottom of the ground of the probe connected to the other end of the coil here. It's got a momentary contact switch that I rigged up there. And that scope comes over here to the Lego table. And you can see here's the scope face. So right now it's set to trigger because I can't get over here fast enough and reach way over there to the momentary contact switch, so we can get an idea of what the waveform is that's being generated in the middle of the field there. So let's come back over here. We'll push the button. Turn it off. Come back over here. That's the most curious digital display. Looks like I need to take it off of trigger and maybe go to a faster time division. Set up for trigger. Alright, let's try that again. And that's just sitting vertically where my nice round butt would fit. Didn't catch trigger once, so that's why I try it again. Alright, let's off the amplitude here. Let's see if we can't grab a time scale. So from bottom to bottom, I guess. So we're looking at about 250 kilohertz for one cycle. So that's definitely not 60 hertz or 120 hertz. 250 kilohertz. Maybe the electrostatic field is being applied to this particular coil and then producing the resonant frequency naturally for the coil. Maybe that coil resonates naturally at 250 kilohertz, which would imply that whatever is in that space, this gap between the top and the bottom plate, would be getting its own characteristics amplified. And it's definitely AC. You can see the sine wave on the scope. So let's try flipping it to the side and see what kind of an orthogonal. I don't know if that's going to reach. Let's try flipping it this way. I don't know if that's not going to stay. Stop rolling for a second. If I put anything else in there, it's going to cause some kind of a influence. I guess let's try and hit it real quick. Take that off. Take it off a marker. Keep it at the 5. Trigger. Alright, put this coil that way. Let's see what we get. Isn't that curious? So instead of a vertical axis, the axis is horizontal and it's an east-west orientation, given the natural ambient field directionality of our planet we're stuck on. That's how the chair is oriented. When I sit in it, I'm facing north. So, okay, so let's see if we can turn it. Oops, popped right off. Hold on a second. Alright. So now it's also horizontal still. This would be, I don't know, X or the Y plane. We did the Z plane first, which is the vertical plane. So horizontally north-south. this marker, take off the hole. Let's set a trigger. Let's get it in. That's quite a big disparity, isn't it? In terms of field affectation. Of course, now I would need to plot the same thing, you know, move it up an inch, move it up an inch, move it up an inch with all three X, Y, Z's, and then, you know, plot it out from there, you know, to make, I don't know, a 1 inch gap, a 2 inch gap, a 3 inch gap, you know, just to get the smile. It depends how fine you want the measurement, right, to be able to go do that shit. Pardon the French. Anyway, yeah, so let's clock this one, which is seemingly much more like the original vertical, it looks like, really. Let's see, so it's right about the same as the vertical. So the east-west was double frequency versus the north-south and a vertical orientation. And that's considering that that's my butt would sit right there. That's 9 inches above the bottom electrode, which is the positive electrode. And my top electrode here is my negative electrode, which has some other random junk, which I don't think does anything, but it's pretty to look at. To me. Obviously other people probably find it as junk. So, anyway, that ion chair. That's my momentary contact switch. There's my permanent switch for on and off, so I can't have somebody sitting there pushing the switch without me around, or without having to switch that. And then here's the configuration, right? This is the input, so the AC comes in here, 120 volts, 60 hertz. It's an oil ignition transformer, comes out. It goes into just any full wave bridge rectifier that you can find on the net. And the output of this transformer is rated at 10,000 volts, 23 milliamps. It's quadrupled and then some, because that's measured already at 50,000 volts, using a pair of high voltage 0 to 30 kilovolt DC meters in series. And that's about 800 PF, roughly, of total capacity at the 50,000 volts. So, that's the ion chair. And those are the current measurements. Sorry if it's a little long.